All right, let's talk about inheritance. It's this core idea in coding that basically lets your code build its own family tree. And trust me, we're going to dive right in, but you need to be warned, it is about to get really weird. I mean, what is even happening here? You've got a baby lion saying, Papa, I am drive class. And the dad replies, Son, I am base class. Is this from some lost scene in The Lion King that was written by a computer science professor? What does this even mean?
And just when you think things can't get any more random, we throw burgers into the mix. Seriously, parent burgers, child burgers, it's a mess. But look, stick with me. I promise you, by the time we're done here, both the lions and the burgers are going to make perfect sense. First, though, we need to talk about the problem they're actually trying to solve.
Yeah, you know the feeling. We've all been there. That sinking feeling when you realize you are writing the exact same chunk of code again and again and again. It is the copy-paste catastrophe. Just look at this mess. We've got a class for a bus, one for a car, and one for a truck. Now, obviously they're different things, but they share a lot of the same DNA, right? They all need a fuel amount, a capacity, and a way to apply brakes. So what do? We just copied and pasted the same code into 3 different places. It's sloppy and worse. If you find a bug in one, you better remember to fix it in the other 2. Total nightmare fuel. But don't you worry, a hero is about to enter the story. A beautiful, elegant solution for the smart and, let's be honest, kinda lazy coder. And its name is inheritance. And boom, this shows you the magic right here. Instead of all that messy copy-pasting, we just create one single parent class, vehicle, and we put all the shared stuff in there. Then our bus, car, and truck classes simply inherit from it. They get all the powers of a vehicle absolutely free. It's clean, it's efficient, and it stops us from making silly mistakes.
So let's put a proper definition on it. Inheritance is just the ability for one class to get its properties and characteristics from another one. The original class is called the base class. That's the parent. You can think of it as the big lion. The new class that's doing the inheriting, that's the derived class, the child, our little lion cub. See? It's all starting to come together.
Now, okay, just like any other family, there are rules. You know, rules about sharing. You don't just go telling everyone all the family secrets. And in code, we handle this with something called access modes. So if a piece of your code is public, it's like yelling something across the room at a family reunion. Anybody can hear it, anybody can use it. No secrets there. But if it's protected, well, that's more like a quiet conversation with your immediate family. Only the parent class and its direct children get to be in on that. And then there's private. Think of this as your personal, locked diary. Nobody gets to read it. Period. Only the class that wrote it can see inside. Not even its own kids can take a peek. Okay, now what's really interesting is how these rules play together. Check out this table. If a member in the parent is public and the child inherits publicly, it stays public. Simple enough. But if that same public member is inherited privately, it actually becomes private in the child. And look at that bottom row. This is the key takeaway. Private members in the parent are never, ever accessible to the child. It doesn't matter how you inherit, they're always off limits.
Right, so we get the family rules now, but it turns out there isn't just one kind of code family. Nope, it's more like a whole buffet of inheritance types, and you get to pick the structure that works for you. Let's check them out. We're about to do a super quick speed run through the 5 main family structures you'll find in the coding world: single, multiple, multi-level, hierarchical, and the mysterious hybrid. So buckle up. First up, you've got single inheritance. This is your classic family tree. One parent, one child. Super simple. You can see here the dog class is inheriting from the animal class. It gets all the basic animal stuff. It's the most common and straightforward type you're going to run into. Next, we've got multiple inheritance. Okay, now things get a little spicy. This is where a child class inherits from 2 or more parent classes at the same time. In this example, our results class is pulling from both student marks and co-curricular marks. It's a really powerful way to combine different features, but, it can get a little complicated. Then there's multi-level inheritance. I like to call this the family dynasty. It's a chain, right? You have grandparents, parents, and then children. So here, the puppy class inherits from dog, which in turn inherits from animal. That means the puppy gets features passed down all the way from the animal class. And look at that, we've come full circle to hierarchical inheritance. This is exactly the pattern from our first example. It's one parent class that has a bunch of different children. The vehicle class is the single parent, and bus, car, and truck are all its kids. They're basically siblings, all inheriting the same core abilities from the same place.
And last but not least, hybrid inheritance. This is it's complicated relationship status of the coding world. It's really just a mix of two or more of the other types we just talked about. You could mash up hierarchical and multiple, for example. It can create some really complex but very powerful family trees. So, after all of that, the lions, the burgers, the complicated family drama, what's the point? What does all this actually mean for you when you're sitting down to write some code? Well, it really boils down to three major superpowers. First, code reusability. You write something once in a parent, and you can use it everywhere. That directly leads to the second power, reduced redundancy, which is just a fancy way of saying less copy-pasting and therefore fewer dumb mistakes. And maybe most importantly, it gives your code a logical structure that actually mirrors the real world. A car is a vehicle, a dog is an animal. It just makes sense. See, inheritance isn't just some dry, technical concept. It's a whole way of thinking. It's about organizing your ideas into logical families, building on the work that came before you to create something totally new and powerful. So now you know how code creates its own family tree. The only question left is, what digital dynasty are you going to build?